Okay, for today, we are going to explore an interesting question. I was asked this question a few times actually. It relates to chi-square. Okay, chi-square. So for chi-square, this is a question. Can we use percentage or ratio or proportions in chi-square, or rather in chi-square test, other than, or rather I'll say besides count, besides frequencies. Okay, so frequencies means the actual counts. So this is a question that I'm always asked, and I know some people may say that you can, some people may say that you may not, but categorically and I will say that no, please do not do that. I say no with a capital N. Okay, so this is very important. No, never use ratios, proportions, and so on. So in other words, please always use counts, or in this case, frequencies, the actual frequencies for chi-square tests. Okay, why do I do that? Okay, let's just have a simple example. Let's just go down, have a simple example. And I say that for chi-square test, for example, my null hypothesis is I say that number of coffee lovers equals to number of tea lovers. Okay, so my now outer hypothesis means that coffee lovers not equals to tea lovers. So there's a difference in proportions. Okay, so here numbers, I can say that although I can change the null hypothesis to proportions, or even percentage. It doesn't matter. Just that I cannot use percentage or proportions. Okay, but I can state the null hypothesis as proportions. Okay, so we have this as the null hypothesis. Let's do that, and we do a simulation. Okay, we do a simulation. So our simulation, I'll use next time. So our simulation criteria is this. We say that 51% prefers coffee. In this sense, it means that 49% prefers tea. Okay, so this is my simulation, and we'll see how does this make a difference. Okay, so let me change it to a purple color, dark purple color. So let's say I do different simulations and try this out. Okay. For example, if I count, let's say I have n equals to 100. So I survey 100 people, 100 people. So this is as good as doing percentage, correct? Because percentage is over 100. So let me try out here. So since this percentage, I will say that I will have coffee versus tea. Okay. Then I have my expected data and my observed data. Okay, so if that is the case, now based on my null hypothesis, my expected is 50-50. Okay, because I survey only 100 people, so I'm expecting 50 to love coffee, 50 to prefer tea. But my simulation says that it is 51 over 49. So far, so good. Okay. Now, what we want to see is what happens here. So we have another column. Let me just take this. And I do others test. Okay. So instead of, so case 1, I'm using percentage. So it's 100 people, as good as 100 people. Case 2, I'm taking 1,000 people. In 1,000, automatically here, if I survey 1,000, I'm expecting 500 versus 500. And here, observed, I'm expecting 510 versus 490. Okay. it meets the same simulation criteria. Then I do for, let's say I'm very energetic, I do 10,000 people. Okay, I survey 10,000 people, so automatically here becomes expected is 5,000 versus 5,000, but still 51 versus 49%. So it's 5,100. Oops. So here's 4,900 and 5,100. So far, so good. So now we do the chi-square test, and here we state the p-value. So chi-square test is quite simple. This is, for example, I just have, so I do a chi-square. So I do a regular chi-square test. Okay, this is a formula, the method for doing chi-square test in Excel using chi-square.test. Actual range is the observed range. Expected range, well, expected. So this is the p-value. That means here, let's say our conclusion. Here we technically accept our hypothesis, correct? Hypothesis. Okay. We do the same for, okay, if accept null hypothesis, we just say, simply I just accept H0. Okay, that makes our life easier. Now I do the same. This means that it's unlikely that what I observe is different from what I expect, because there's 84% chance that the null hypothesis may be true. So I do the same for 10,000 and see what happens. Chi-square test. Again, actual, observed. What you begin to see is the p-value actually do change. Because the p-value do change, it already tells us we cannot use percentage because the sample size does make a difference. However, we are lucky that we still accept the null hypothesis. Correct? Because it's nearly 53% that the null hypothesis may be right. Now, how about 10,000? If I do the same, chi-square test, actual, observed is this, and expected. You see, now it becomes less than 0.05, which means that now I will have to reject my null hypothesis. So this tells you that, look at these three p-values, it changes with respect to proportions, with respect to the sample size. And as a result, the conclusion do change as well. Or rather, I use the screen. So the conclusion do change. And this is the reason why you should never, I'll say, I'll capitalize it and then put it in red. And I say that this is why you should never ever use percentage, or in this case ratios or proportions, in chi-square test. Okay, which means that I'll say that always use the actual frequency or the count itself in chi-square test. Okay. This is very, very important because you can have errors. Now, this also means that, this is why I categorically say no. This also means that if anyone were to tell you that, yes, you can use percentage, ratio, or proportions, please show them this example. You cannot use percentage, ratio, or proportions because the p-value change. Okay, hope I get this clear this time. Thank you very much.